Okay, at some point in the future, you're going to come across nonlinear equations that you're going to have to graph. And with a linear equation, solving for the intercepts is easy. For a nonlinear equation, it gets a little bit harder. So, and that's because, as you're going to see, you're going to have more than just two intercepts most of the time anyway. You may only have one intercept for an equation. So being nonlinear, even though more realistic, we don't live in a linear world, we live in a nonlinear world. Even though more realistic, is more complicated mathematically. Now, the typical nonlinear equation we're gonna, or that most people deal with, is one that simply takes the form y equals ax squared plus bx plus c, okay, where a, b, and c are coefficients. Now, normally, to solve for y is easy, okay? We just put in or solve for y's intercept is easy. We just put in 0 for x, and then we find that y's intercept is c. But what about solving for x's intercepts? And that becomes a little bit more complicated. Now, we can do that one of two ways. The most popular way that everybody was taught to memorize is using the quadratic formula. Okay, and we all remember that as x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, and remember, make sure that your division bar goes all the way across. You see how I had to extend that a little bit because it did not cover the entire numerator. Okay, just make sure you got to be accurate in mathematics when you're doing things like that. I've mentioned this before. But anyway, you could just plug a, b, and c into this equation here, and you'll get two values of x based upon the plus and minus signs. Or you could do something called completing the square. And completing the square goes something like this. So assume you have y equals x squared plus 2x minus 3, okay? Well, we set this equal to 0, so because that's where you're going to find x's intercepts, right, is when y is 0. So we set this equal to 0, and we get x squared plus 2x minus 3 equals 0. Now, what we do when we complete the squares, we go through a few steps to lay the groundwork for actually completing the square. The first step is to make sure that first coefficient, that a coefficient, is equal to 1. And we'll see an example in a minute where it's not equal to 1 and we have to make it be equal to 1. But right now it is equal to 1, so it's easy. The next step is to move c over to the right. So that's x squared plus 2x equals 3. Then we're going to take 1/2 of b and square it. Okay, 1/2 of b, so b is 2. We're going to take 1/2 of that and we're going to square it. Now in our case this is easy because this equals 1. Okay, that's 2 times 1/2 is 1, 1 squared is 1. Now we're going to take this 1 and add it to each side. So that gives us x squared plus 2x plus 1 equals 3 plus 1. So this gives us x squared plus 2x plus 1 equals 4. Now, what makes this easy from here is the fact that this is now a perfect square. And the perfect square is x plus 1 squared. Okay? If you take x plus 1 times x plus 1 and you FOIL that out, you're going to get exactly that. So taking 1/2 of b and squaring it and adding it to that left side gives us a perfect square. Well, this equals 4. Now we can just solve for x easily. So we're going to take the square root of each side in order to get rid of that square term. That gives us x plus 1 equals, okay, now remember, if I take the square root of something, I'm essentially searching for its absolute value. Okay, so I've got plus or minus the square root of 4. So then x equals -1 plus or minus the square root of 4. Simplifying that, which you always should do, we get x equals -1 plus 2, which equals 1, or x equals -1 minus 2, which equals -3. Okay, and these are the x-intercepts when y equals 0, using completing the square. And if you took this information and plugged it back into the quadratic formula, you would see that you're going to get exactly the same answers. Let's do another one. Let's do this one. 11x squared minus 12x plus 1. Okay, y equals that. Okay, so in completing the square, in order to solve for the x-intercepts, we're going to set this equal to 0. 11x squared minus 12x plus 1 equals 0. Now, okay, now we don't have a equal to 1. We need to make it equal to 1, so we're going to divide through by 11. So dividing through by 11, I get x squared minus 12/11 x plus 1/11 equals 0. Now we're going to move the 1/11 over to the right. That gives us x squared minus 12/11 x equals -1/11. Okay, now I'm going to take 1/2 of b and square it. Now because I'm squaring it, I can ignore the negative sign. So b is 12/11. I'm going to take 1/2 of that and I'm going to square it. That gives me 12/22, and that is squared. And that should give me simplifying this a little bit, that should give me 6/11 squared. Okay, now I'm going to add that to each side. So this gives me x squared minus 12/11 x plus 6/11 squared equals -1/11 plus 6/11 squared. So now on this side I should have a perfect square. Okay, and what is that perfect square going to be? Well, it's going to be x minus 6/11 squared. Okay, now again, in order to validate this, you can simply expand it to x minus 6/11 times x minus 6/11 and FOIL it out. And what do you get? You get x squared minus 6/11 times x minus 6 over 11 times x plus 36 over 121. Okay? This gives us x squared minus 12/11 x plus 36 over 121, which is exactly 6/11 squared. Okay, so we get the same thing back. Okay, going back here now. So what do we have? We have a perfect square on the left, x minus 6/11 squared equals negative 1 over 11 times, or excuse me, plus 6 over 11 squared. This equals negative 1 over 11 plus 36 over 121. What does this give us? This gives us x minus 6 over 11 squared equals, okay, so now we're going to find a common denominator, negative 11 over 121 plus 36 over 121. Okay, now this here equals 36 minus 11, which equals 25 over 121. Okay, so now we have this, and we have this on the right. We're going to take the square root of each side. This gives us x minus 6 over 11 equals plus or minus the square root of 25 over 121. Okay, so now we get x minus 6 over 11 equals plus or minus 5 over 11. Okay, simplifying this further, bringing it back up where we got some more paper, this means that x equals 6 over 11 plus 5 over 11, or x equals 6 over 11 minus 5 over 11. So 6 plus 5 is 11, that's 11 over 11, so x equals 1, or x equals 1/11. And that's solving for your x-intercept using completing the square.